screen? Boleh?
Boleh.
Boleh.
Okay. So today our new topic, parameter setting. Okay, parameter setting. This is the what we call the main objective for this topic. Number one, to define or to introduce parameter control. Okay, algorithm parameter. Sekejap, ada orang nak masuk lagi. Okay, introduction to algorithm parameter, and second, to classify the parameter. Actually, we have two type of parameter. Okay, we need to define the parameter. For example, parameter mean number of iteration, for example, number of population. Okay, that the parameter that we need to decide for optimization, and then the mutation percentage. Okay, so how to decide, how to determine that parameter? So we discuss after this, and then the example of parameter. Okay, the introduction. Okay, the one of the main difficulties of applying EA to a given problem is to decide appropriate parameter values. Okay, to determine parameter values. Typically, these are specified before the algorithm is run. Then, for example, of parameter, population size, for example, selection rate, operator, probabilities of mutation, and so on. That the parameter, and then that actually we don't have any specific criteria to determine the parameter setting. Okay, usually we determine by experiment. The parameter setting by experiment mean first experiment we set maybe number of iteration 1000, then we run. The second experiment we increase to 2000 iteration, then we run, then we keep the result. And then third experiment maybe we increase to 4000, 5000, 500, for example. Then we compare the result. Oh, maybe iteration 2000 is the best we use for this problem. So based on experiment, or the number of population. Okay, number of population. Maybe we set 10 population or 20 or 15 or depend. And then based on result that we have, so we can make conclusion. maybe population number 10 population is the best compared to other population, number of population. Okay, then setting value for parameter EA is crucial for good performance. Okay, then the main objective is to make sure that our application, okay, during we run that application is in a good performance. So how to measure, how to determine, how to make sure that our system in a good performance? So we need to try and error the result or the value of parameter. For example, GA require population size, probability of mutation and crossover, tournament size. This called as algorithm parameter or strategy parameter. And then for setting a parameter, help in finding optimal, near optimal, or efficient solution. This is the main objective, to find the best efficient solution lah. And then choosing the right parameter is a hard task. Hard task because tedious work. We need to repeat the same experiment but different value of parameter. So we should play around with number of parameter. Then we should analyze that result, and then based on that result, we can make a conclusion lah. Which parameter is the best for this problem, and then we should know that each problem is, for example, problem 1, problem 2, problem 3 is different problem, so the parameter value is different. Okay, we cannot use the same parameter value. Sometimes for problem A, parameter value the best maybe population is 10, but sometimes another problem the best population maybe 15 or 20, depend we define the coding and also the problem that we cater. Okay, and then an EA practitioner have wanted to know the answer to question like, are the optimal setting for parameter of EA in general? It is desirable to dynamically change parameter value during EA run, and then how do change in parameter affect the performance of optimization or EA. And then the parameter of optimization, usually we consider the first, we should think about the parameter the mutation rate, the crossover operator or crossover rate, okay, selection mechanism, for example, using elitism, for example, or tournament size or roulette wheel, and then this is the mechanism of selection and the population size. Usually we should consider four item or four criteria or item, for things to try and error the value of this parameter. And then good parameter value facilitate good performance of our system. And then how to find a good parameter value? How to find? So usually using try and error. Experiment lah. Experiment. And then actually here to what we call to determine the value of parameter, we can do manually. Okay, manually mean experiment lah. And then second, we can ask computer to find. Okay, to find the best value of parameter ni using adaptive process. This is the dynamic. Okay, mean during adaptive process ni, during the running the parameter may vary during a run. So the parameter keep better and better lah. But to implement adaptive technique, this is difficult. Okay, this is very complex, very tough lah compared to manually practice. Okay, so adaptive process programming code, we should orang kata apa? Because involve learning process, okay, learning process, adaptive based on comparison and so on. So this is more complex compared to the first one, manually. Clear? Boleh follow setakat ni? Or should I repeat again? No need.
No need, sir. Boleh continue.
Boleh. And then question number 2, how to vary parameter value. So the parameter value we can, this manually we can for size, too large and too small. What happen if we put the number of population too large? What happened to the system? Okay, so you are going to have a long epoch time. For epoch time mean iteration. Okay, number of iteration mean for one iteration maybe takes long time to finish. Takes time to finish for one iteration for population, large population. Okay, this is the disadvantages lah. And restricting how many changes each individual has to explore its neighborhood. But too small. If too small population, you don't get good coverage of the search space because too small population. For example, you have more than 1 million solution, but your population you just set maybe 10 population only. So this is too small compared to the total population. So this difficult lah to get a good solution for this problem. So maybe you can put 1,000 population or 100 population, at least 100 lah usually. Kalau 1,000 too big because need time to evaluate. Okay, that one for population size. How about mutation rate? Mutation rate, if you put mutation rate too high, you risk the individual jumping over a solution they are close to. Okay, mean difficult to find the optimal solution if mutation rate too high. But too low, they are going to get stuck in a local minima. So that's why I say, so we need to do the try and error to get the best parameter value for each problem. So it really does depend on your own particular search space. Experiment with the parameter and try to find the optimal combination. So I would agree that using another GA to optimize the parameter is not going to solve the problem. Okay, for example, another this is the sample of ni lah, sample of interface. So you can set like this, the mutation rate, the crossover rate. Okay. And then ni lah. And then okay, for parameter setting we have two type. Number one, this is normal practice lah. This is manually using by experiment. This is manually. This is machine or computer control. Computer control. Okay, manually mean before we run that system, we need to define, or we need to set the number of population, mutation rate, and so on. And then this type we call parameter tuning. But another one more type we call parameter control. Parameter control mean during the running, the computer try to find the best value for each parameter. For example, mutation, number of population, and so on lah. So this thing we call parameter control. Parameter tuning we done before the running, but parameter control during the running system. This done by computer. This is human. This is computer managed, computer done. And then for control, parameter control, we can what we call manage by for type or for category based on time dependent. Mean we set the time maybe during 5 minutes, or we allocate 5 minute time for computer to find the best answer. Okay. Or adaptive mean feedback from search, or self-adaptive coded in chromosome. Okay, this is the most difficult task to do compared to 1 and 2. This is the highest the highest complexity compared to adaptive and deterministic. Clear? Explain nanti.
Clear, sir.
Clear kan? Yang lain? Okay. Okay, then for parameter tuning, offline parameter, okay, simple parameter swap. We try everything. By experiment lah. We try an error. Okay, meta GA on top of GA, and then usually we using experiment by experiment, this one. And then parameter control, 3 type: adaptive, self-adaptive, and deterministic. For example, okay, this but I think I no need to explain because we just discuss baru aja. Think go through the slide ni. This parameter tuning. Okay, but parameter tuning is time consuming because it takes time. We need to repeat the same process. Okay, repeat the same process but with different parameter value, and then we need to analyze manually. For example, the graph that we have, for example, like this kan, katalah this graph, and then this is the result 1, experiment number 1. This is experiment number 2, and then this is what we call fitness function, and then this time the number of iteration. Okay, fitness function, number of iteration. Okay, you think which ni experiment 1, experiment 2. Okay, which graph is what we call have good quality? Experiment 1 or experiment 2? You think?
Experiment 2.
Why?
Learning rate dia lagi cepat kot.
Learning rate? Why is it learning rate? Here don't have learning rate.
Oh, I mean, sorry.
Why? Tapi dah betul. Experiment number 2. Yeah, number of iteration less compared to experiment number 1. Experiment number 1, number iteration kat sini. Maybe this one 1000. We at 1000 this point, at this point we have convergent value. Convergent value mean the value of for fitness function fixed. Might mean no increase. But before 1000, the number of the value of fitness function keep increase till at one stage kat sini at 1000 iteration, the value of fitness function just static. Okay, I mean for iteration increase but fitness function not increase. Tapi for experiment number 2, maybe this one maybe 500 iteration, we have convergent value at this point. So that's why the experiment number 2 ni better than experiment number 1 because of number of iteration less. Okay, so that's why we need to analyze the what we call the result. That's why time consuming. So you imagine if we have 20 experiment or 550 experiment, so we need to evaluate every single graph ni. So that's why the process is time consuming. Okay. Okay. And then actually for your tutorial this week, you can draw down graph. For example, for iteration 1 for knapsack problem kan, iteration 1, you can draw graph like this. Tengok the pattern. This is number of iteration. Okay, this is fitness function. So for the first iteration, you select the best fitness function for list of chromosome tu. Maybe the point at this point kat sini. The second iteration maybe at this point. The third iteration, sebab dia keep increase kan, sebab the what we call the value of fitness function tu, we using elitism, so that's why we cannot increase the value. So then you after this, then you just we can see the pattern of the graph like this. Cuba you buat, boleh tak dapat graph macam ni. And then iteration number 3, iteration number 4, kalau sampai 10 iteration, tengok the pattern of graph. Kalau 4 iteration, just 4 point mungkin susah sikit nak nampak the what we call the pattern. Tapi kalau you boleh buat sampai 10 iteration, so maybe you can get the pattern like this. Boleh dapat graph like this. First, fitness function for y, x, number of iteration. Clear? Kalau group A, tomorrow tutorial. So tomorrow we discuss again untuk yang ni. Untuk yang tutorial knapsack problem. So untuk yang group C and B, so you try solve that problem using genetic algorithm, then plot the graph. Then next week, show me your work. Show me your work. Faham ke? For group B and C, faham ke tak faham?
Buat
based on tutorial question kan sir?
Ya, tutorial kan I dah bagi
Dekat you feature tu kan?
table tu kan. Table we have 10 item tu. Ingat tak?
Oh, knapsack.
Knapsack.
Oh, okay.
So knapsack tu you buat sampai 10 iteration manually. Then for each iteration you keep the value yang the best value tu. Then for one iteration 1 point graph. Kalau you have 10 iteration, so you have 10 point. So 10 point tu you just link je lah. You just connect je. Then you can see the pattern of graph. Macam mana. Just manually, tapi kalau komputer lagi cepat lah. Komputer will, orang kata apa, automate. Buat programming, just lagi senang. Bukan lagi senang lah, maksudnya kena buat coding lah. Tapi this manually. Study guna cara manual dulu. And then for to polish your skill, maybe you can try find coding for knapsack problem. I tengok dekat internet banyak coding for knapsack problem. Then try modify, run that program, see what happen. Then try to understand the flow of ni lah algorithm dia tu, coding dia tu. Cuba run. Dekat guna Python pun boleh. Ataupun guna apa-apa je. So, barulah you appreciate the ni optimization punya apa? Punya method. Okay, that one for ni parameter tuning, the drawback. How about parameter control? Parameter control done by machine, computer control dekat ni. Computer do for us, computer. Parameter tuning, human. Human do the try to find the best parameter value. That one for parameter ni. Parameter tuning, for parameter control, computer do the process. In classifying parameter control technique of EA, many aspects can be taken into account. For example, the changes, what is changed. For example, the representation of chromosome, for example, evaluation function, operator, selection process, and so on. And then how the change is made by deterministic heuristic or feedback or self-adaptive. Okay, as I said, self-adaptive more complex compared to the first one and the second one. Deterministic heuristic usually by time by deterministic ini by based on time. Okay, based on time. And then the evidence open the which the change is carried out. For example, monitoring performance operator, diversity of population, and so on. The scope of level changes, population and individual level, and so forth. Okay, this is the parameter control. Okay. Okay. Consider the chart. This is the general GA, general optimization using GA. Okay, this is the adaptive framework, self-adaptive like this. Kejap self-adaptive. Kejap, mana tengok. Okay, consider this what we call framework. Mean for self-adaptive, we using GA about GA. Meta GA. Because we have double GA here ni kat sini. Okay. using reinforcement learning kat sini. Okay, then this is the parameter. Then to set the parameter, we using first GA here kat sini, and then another GA we using another GA here to evaluate the number of population. Okay, so this for your information lah, dalam exam tak masuk lah untuk this what we call framework, because very complex algorithm to explain. GA about GA, meta GA. Mean the parameter to be adapted encoded into chromosome and undergo mutation and recombination. The better value of this encoded parameter lead to better individual, which in turn are more likely to survive and produce offspring. Hence, propagate this better performance based on parameter values done by computer. The program will analyze the result. Then after that, summarize for us, then show the best result. That one, and then this is the we call the algorithm for self-adaptive learning. And then for parameter control, we have 3 types. For deterministic, mean some rule modified strategy parameter without feedback from the search. Okay, and for adaptive, feedback rule based on some measure monitoring search progress, and self-adaptive by encoded onto chromosome. They undergo variation and selection. And then for parameter, usually we all consider the what we call the criteria ni, the function, the population, individual and sub-individual. And then the conclusion. Okay, I nak you go through the conclusion, then which part you think that we should explain then or discuss, so then we discuss. Go through the conclusion. Okay, the reference you can go through this article. So for this topic, we can conclude that to determine the parameter, we have two types, by tuning parameter and control parameter. Control parameter have 3 category. So 1, 2, and 3. Tuning by experiment, control by machine. Machine mean we need to do the programming. We need to do programming for to control the machine. Okay, so that's all for this topic, parameter tuning. Any question that you want to ask? Ada soalan?
Kami tak ada, sir.
Okay, so yang lain ada?
Tak ada, sir.
Kalau tak ada, for next week, our new topic, particle swarm optimization. So make sure you download this what we call this slide, then try to understand, go through this slide, then we discuss next week for particle swarm optimization. And then this week I nak you all today lah, I nak you all ada masa lagi ni, so we discuss on individual project and group project. So for individual project, how the status? Macam mana the status of individual project? Give.
Still ongoing, sir.
Okay. Tajuk dah ada? Dah ada kan?
Dah ada, sir.
Semua orang dah ada tajuk kan? Ada yang belum? How about group project? Group project dah ada tajuk belum?
Dah ada.
Dah ada, sir.
You dah letak dekat I discuss kan?
Belum untuk tajuk.
Oh belum, okay. So I nak sekarang you letak hari ni lah. I nak you discuss among group member ni. Your title nanti I letak I letak dekat group. Title, group project, and juga individual. For group project tu you yang ketua je lah post. Kalau yang individual tu you need everyone, you need to post the title of project, group project. Kita tahu kan untuk yang individual project nak buat apa kan? Find one article, then please comment the article. Comment mean you summarize lah the goal, the objective, and so on. Faham ke tak faham?
Literature review lah kan, Sir?
Literature review. Cari
Based on one article je ke, sir?
One article aja. One mean you first you need to decide the problem punya domain. Problem domain apa you nak solve. Sama ada timetabling ke ataupun travelling assessment problem ke. Yeah, that one the easier. Just not complex. So complex lah kalau TSP. Kalau yang lain-lain pun up to you. Maybe delivery system using GA, you cari one article, then based on that article you just you follow lah the format. So first the goal for what this article, this title untuk apa, the fitness function macam mana, the variable involved apa dia, and so on. That one for individual. Then you boleh tengok juga untuk artikel yang lain untuk nak dapatkan dia punya some, orang kata apa, idea nak tulis tu. Tengoklah artikel yang lain, jangan satu je. Then artikel yang you ambil tu make sure biarlah senang faham. Jangan ada beberapa artikel, ada separuh artikel tu bila baca tak faham. So tak perlu consider artikel yang tu. Consider artikel yang senang awak faham, then easy for you to explain. Clear?
Clear, sir. Thank you.
That one for individual project, no development. But for group project, show the system. You need develop one system, optimization system. Then you need to you need to present. Then during presentation, show me the system. So make sure no error during presentation. The system perfect. Working lah maksudnya. So you pilih yang simple system tak apa optimization, sebab saya tahu kalau you nak buat yang susah, yang kompleks, susah nak siap. So pilih yang simple macam knapsack problem, or TSP, or timetabling. Up to you. You decide. Okay, so tapi by today I nak dapatkan title je dulu. Individual and group. Boleh?
Boleh sir.
So ada masa ni, you browse internet, dapatkan ni yang info yang saya nak tadi, then by today you need to post lah the result. Okay? So kalau tak ada soalan, we communicate through WhatsApp after this. Yes or no? Okay ke tak?
Okay sir.
Okay, sir.
So jangan membazir masa. Masa ada lagi 1 jam untuk awak cari related information dengan untuk ni lah project ni, group and individual project. Okay, so you dah ada group ke belum? You all?
Dah, sir.
Dah form group. Okay, so dah form group. So nanti you post juga dekat dalam I discuss. Nanti I create I discuss sekejap lagi. Alright? Okay, bye. Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam.
Thank you, sir.